In this video, I'm going to show you how to test the normal distribution of data for continuous variables. Okay, and I have a data set here with 4 variables: profitability, initial capital, credit access, and the net sale. These 4 variables, when we consider the profitability, the variable profitability is continuous, initial capital is continuous, net sale is continuous, but credit access is the variable that consisted the data which was asked from the respondent is whether or not the enterprise in which they are the enterprise that they are owning access it or not access it credit. So it is a categorical variable. Okay, and when we are about to run the normality test, we only run a normality test for continuous variables or scale variables. Metric, the variable should be measured in metric terms, okay, in continuous numbers. So here in our data set, we have profitability, initial capital, net sale variables which are continuous. So we're gonna run normality test or based on this for this 3 variables, and now let us go here and analyze descriptive. There are many ways, and I will show you. Let me reset because I was working and let us move this behind the variables. You see the sign, okay, the ruler sign and the flower sign, and the flower sign indicated that the variable is categorical variable. And as I've told you at the outset, we should not test the normal test for categorical variable. We only test normal distribution of data for continuous variables. So profitability, initial capital, net sale, we move them to a variable box. And in the statistics option, we go for mean, median, and skewness, kurtosis. We are not interested in other statistics, but the chart, let's go for histogram and show a normal curve. Continue, and the display frequency table, and okay. Here, as you see, the output is generated, the SPSS output generated the output, and here is the skewness and kurtosis. We can all consider them for interpreting the whether the data is normally distributed or not, and we can also compare mean, median, and mode for the normal distribution of data to judge whether the data is normally distributed or not. And actually, the skewness of the skewness of the data should be between -1 and +1. Kurtosis, the same thing. But for our case, let us go to the histogram and just simply observe. Okay, look up profitability here. Seems not normally distributed. A normally distributed data is a data that makes a true bell shape, that is distributed equally right and left. But here, as you see, it is negatively skewed. Okay, it is negatively skewed. Initial capital, again, it is negatively skewed. Net sale, it is a little bit normally distributed, but is still negatively skewed. Okay, and the one thing that you have to put in your mind is that there is usually not perfect normal distribution. It is it is relative, and here for net sale it seems normal distributed, but it is still negatively. It looks like negatively skewed. Let me show you another normal distribution test way, and it is explore. Let me reset. Okay, and we move this scale variables or continuous variables into dependent list. net cell, all this variables. And in the statics you go for descriptive. You can also check for outliers, plots, histogram. Okay, histogram and the normality plot with testes. And then let us pause this. We have to check this pause statics and the plots pattern, and we click on OK. Then look here, the data. Okay, the SPSS generate output. Okay, for profitability, it generates all the statistics. For initial capital, the same thing. For the net sales, the same thing. And here, test of normality, the Kolmogorov and Smirnov test, and the Shapiro-Wilk test is here. And you see here the p-value, okay, are all less than 0.05 or 0.01. Okay, let us extend the significance level. And for all, for all the variables, profitability, initial capital, and net sales, it is less than 0.1, which is it seems significant. And the null hypothesis of the test of normality is that the data is normally distributed. And here, the p-value less than 0.1 indicated that our data are not normally distributed. Our data, the data in the profitability in the initial capital are not normally distributed. The same thing is true here. It is less than 0.1. Okay, or 0.5, all of them are less than 0.05. Okay, not 0.5 but 0.05. And it seems that the data is not normally distributed. Okay, and you can to support the Kolmogorov, Smirnov test and Shapiro-Wilk test. You can observe here the histogram, and it seems that not normally distributed, but it is it's inclined, or it is skewed to the left. You can draw the curve on like this distribution curve. It seems that negatively skewed. And here, as you see in the normal QQ plot, that you look, the data run out from the line, okay, the normal line. And in the returned normal the plot 2 histogram for initial capital, it is not still normally distributed. You can check by showing the normal curve. It is negatively skewed again. And here for the net sale, it is relatively good, but you can show the distribution curve and look here. It is really relative to the first two variables here. It is very good. It is somewhat good, and mind you, it is not always possible to get a perfect distribution. Okay, if we found slightly normally distributed data, then it will be sufficient to run the test or the model of our interest. Mind you, when the data is not normally distributed, you cannot run parametric tests like ANOVA. You cannot run a parametric tests like independent sample t-test, paired sample t-test, one sample t-test. Okay, the data should be normally distributed, and this is all about how to test the normal distribution of data. And thank you very much.